Okay, we're starting investigation 8, which is air pressure and wind. Here are some of the vocab words that we have for this section: atmospheric pressure, air mass, Coriolis effect, differential heating, doldrums, isobars, jet stream, and prevailing winds. Some of the labs that we were going to be doing, the first one is going to be looking at air pressure, and we're going to set up a plastic bottle and a glass jar with a rubber stopper and a plastic tube inside of it. And right here it gives us the instructions for setting that up. Okay, we're going to fill it up halfway, and we're going to dye the liquid inside just to make it a little easier to see. Put the rubber stopper into the glass bottle, and then we're going to position it upside down inside a glass jar, or a plastic jar, with the lid screwed on tightly. So here is the lab, and as we go to squeeze, we can start to see what's going to happen inside. So as we squeeze, we could see that the liquid is going down in the tubes. As the liquid goes down in the tubes, we can see the air pressure inside when we squeeze decreases the volume inside the plastic jar, and that's going to increase the pressure. That increased pressure is going to push on the air inside the tube, forcing that water down and forcing it to go back inside the jar. As that goes back down inside that glass jar inside, the air pressure inside is going to start to get compressed because the water is going to fill up that glass jar, and it's going to decrease the volume for the air inside, putting that under pressure. And as we continue to squeeze this, we're going to see that that expanded air pressure inside is going to then push back on the water inside the glass jar, forcing it back up the tube, and it will then spill out into the plastic jar. So we have some of the answers to the questions for that lab. We had to write a prediction on what we thought was going to happen. Then, as we've seen in the beginning of that lab, we see that the water goes down in the tube when we first squeeze on it. The reason that it goes down, again, is because when we squeeze in the tube, we increase the pressure inside. That increased air pressure will push on the water, forcing that water to go back inside the glass jar. As that water goes back down the tube into the glass jar, it's going to decrease the amount of space for the air inside that glass jar. As that air gets a decreased volume inside the glass jar, its pressure also goes up. And then here the third question: if we reduce the air pressure inside the jar, what would happen to the level of the water in the clear tube? And that's what we've seen happen at the end there. With that air under pressure inside the glass jar, when we then let go of the plastic jar, the amount of space for that air in the plastic jar increases, which now means it has more space. It then has more room to move around, which is a lower pressure, and that air inside the glass jar can now expand. The only way it can expand is by pushing on the water inside the glass jar. The only place that water can go is back up the tube, and then it spills out into the plastic jar as that continues to expand. So they have it written here: there would be less pressure in the system, so the air inside the glass bottle would expand, pushing the water up the tube. After that, we read through the article on air pressure. Okay, with this article on air pressure, it talks about what the air pressure is on Earth, how that air pressure can change, how we feel that change in air pressure when we go to different elevations. We also talked about how that affects humans as we move around to different areas, the amount of oxygen you can get, for instance, climbing up like Mount Everest, or playing sports at higher elevations or lower elevations. Then we started talking about barometers and measuring the amount of air pressure in different areas. So we talked about Torricelli and making his mercury barometer, and then aneroid barometers here with the springs inside of them. And then we finished off the article, and we went over some of the questions at the end of that article. Here are some of the questions at the end of that article. When you drive down the mountain, what makes your ears experience those interesting and sometimes uncomfortable sensations? When you go up the mountain, the pressure in your inner ear is the same as the surrounding air. As you drive down the mountain, the lower elevation, the air pressure increases. The air pressure pushes on your eardrum, compressing the air in your inner ear and straining your eardrum. When the air flows from your throat into your inner ear, the pressure difference across your eardrum equalizes with a pop. Okay. Then they have some other questions here. Why doesn't an empty soda can get crushed sitting on a table? The air pressure inside and outside the soda can is the same, so the pressure is pushing on the inside of the can outward, as well as the pressure pushing from the room on the outside of the can inward, and they balance each other out, or they are equal. Okay? If a meteorologist says the pressure is getting lower, what would we expect to see happen to Torricelli's mercury barometer? And the level would go down. There wouldn't be as much air pushing on the mercury in the bowl, so the bowl would fill up more, and the mercury would come down the tube inside of the barometer. And if Torricelli had drilled a hole in the mercury barometer, what would happen to his barometer? The mercury would flow out the bottom of the tube because air pressure would push down on the mercury through the hole. It needs that vacuum at the top for the barometer to work. And the last thing, we did a little worksheet. Most of the classes did this for homework. We talked about Derek at a camp. He was in a high elevation in the mountains. Finished a water bottle, closed it tightly, put it back in his backpack. Went home to Seattle 3 days later, and when he unpacked his bag, he found the bottle crushed, and then when he opened it, he heard a hissing sound. Since Seattle is near sea level, there's a definite change in elevation, and they started off at about 2,400 meters, and they get back down to sea level. There's less air at 2,400 meters, so there's not as many air molecules inside the bottle, so the bottle is not able to push out and stay full size. The air pressure surrounding it when he's down at Seattle at sea level is greater, so it collapsed the bottle and gave it that little bit of a crush because of the less air pressure in the mountains compared to the air pressure in Seattle. If you have any questions, feel free to stop by in class and ask.